is our last day of new learning for this unit. So, what we're talking about? We're talking about graphing linear inequalities on a coordinate plane and shading, right? So, what we've seen so far is we start with the equation. We've done equations all year. We talked about like 6x equals 60. You divide by 6 on both sides. You get x equals 10. You get one solution in an equation. Then we talked about inequalities. 6x is less than 60. You divide by 6, you solve, you get x is less than 10, right? We graph it on a number line. There's a ton of different solutions, and there's only one variable, so we only need one axis. Well, today we're going to introduce that second variable. We're going to talk about x and y in the same problem with inequalities. We're going to do a linear inequality. Right? What's going to happen is we're going to end up getting a line, and we're going to have to shade one side of the line to the other because there's many solutions that actually fit our equation, or excuse me, our inequality. So we're going to talk about how we're going to use this just like we would an equation when we're graphing, but because it's an inequality, it has more than one solution, so we're going to shade one of the two sides of that line. So if you look at this first problem here, or excuse me, never mind, that's in a second. A linear inequality describes a region in the coordinate plane that has a boundary line. So what we are going to do today is we're going to do things like this first graph and the second graph, where we have a line, and we're taking a part of our coordinate plane and we're shading it. We're making it into our answer. So like I said, a linear inequality describes a region in the coordinate plane that has a boundary line. This last picture over here, we're going to be doing that next unit, in Unit 8, Solving Systems. We're going to graph what we call a system of inequalities. So we're going to have more than one inequality on our graph, and where they overlap is where we're going to shade. Like I said, we'll do that next unit. This unit, we're just going to focus on these two on the left and in the middle. So, what do you notice with the line here? Look at this graph. Y is greater than x plus 4. What do you notice about that graph, that line, anything? It's going up, so it's got a positive slope. All right. Yes, Carl?
It's dotted.
It is a dashed line. Why do you think it's dashed?
Because
Because
it's
it's
less
not,
than.
ooh, no, because it's not or equal to.
Oh,
So,
yeah.
what happens, guys, just like how on a number line, we had the open or the filled in circle, we're going to have a dash and a solid line. So if it's or equal to, if we can include the points on our line in our answer, it's going to end up being a solid line. If it's a dashed line, that means it's not or equal to. It means we can't include anything on that line in our actual solution set. All right? What do you notice about this one?
Solid line.
It's a solid line. Why is that, Cam? Why do you think it's a solid line? What did I just say?
Equal to.
Because it's or equal to. Very good. It's got that line underneath. Yes, sir.
The sign is reversed when it's on the opposite side, but it's open.
So yeah, so there is a way, I'm not sure how people do it, depending on like which way the sign faces is the way you shade. It doesn't work in every single instance, so we don't teach that way. I mean, and I never learned that way, but that's a very good observation. I'm going to show you a way where we use a test point. It's actually really easy to know how to shade. So if you know the other way, go ahead and use it. Like I said, it doesn't work in every single instance. Alright, so before we can do an inequality, let's just graph a line. Y equals 2/3 x minus 4. How do I graph a line like that?
Put in the negative 4.
What's that?
You can put in the negative 4.
Put in a negative 4?
You put the negative 4.
Like on here, you mean?
Yeah.
Well, what is negative 4? What is the what? The y, not axis, that's the whole thing.
Isn't it where, like, the line goes?
Where the line goes through the y-axis, which is what we call the y intercept. Good, those vocab words. So, our y-intercept, or b, is negative 4. So at my y-axis, on negative 4, I'm putting a dot. What else is really important there to help me graph it?
2.
The 2, okay. Well, 2 is with something else.
3.
2/3, right? My slope is 2/3. 2 up, 3 over, right? Rise over run. So up 2 over 3. Up 2 over 3. Alright, and then I can draw my line out once I have a couple things by using my straight edge. Right? Hey guys, if you don't have a straight edge, I have plenty of them you can borrow for the test. Right? If you decide not to use a straight edge on the test and your line is all janky and wavy and things like that, it will get marked wrong, believe it or not. So, I have plenty of straight edges. Look at this big pile of straight edges that I have. If you need to borrow one for the test on Wednesday, ask me for one. If you have like an ID card you want to use that. If you have something else you want to use that. I don't care. But you must have straight lines. It can't just be waving all over the place. Alright? Another thing with our graph. If you're drawing a line, it needs to go through your whole graph, guys. Right? Don't stop it like right here. It doesn't stop there. Don't stop it here. It doesn't stop there. And to go with that, you must have arrows. It'd be a real shame if you did the whole problem correct, and you got it marked wrong just because you didn't put arrows on your line. Right? If you don't put arrows, I'm going to mark it wrong, because your line keeps going. It doesn't stop. Alright? Those are my 3 big rules. You need to be straight, so use a straight edge. It needs to go through that whole graph. It needs to get to both sides. And it needs to have arrows. Alright? Those are my big rules of graphs. Any questions on graphing a line? Cool. What about standard form? 5x minus 2y equals 10. How do I graph that? How do I graph that?
Up 5 back.
What's that?
Up 5 left.
Not going to up 5 left 2. Willie, what do you think?
Grab the first point at -2 on the y-axis.
Not quite. Okay, so there's 2 different ways we can do it, guys. The way Ryan just said to me is he wants to subtract 5x first. That's fine. He's going to solve for y. Perfectly okay. I'll do that first, but then we can also use the cover-up method. Alright, so let's solve for y first. Subtract 5x. Negative 2y equals negative 5x plus 10. And then divide by negative 2. I get y equals 5/2 x minus 5. So now it looks like the other one. Now it looks like y equals mx plus b. So I have a y-intercept of negative 5. I have a slope of up 5 over 2. Up 5 over 2. Then go ahead, I can draw my line in, and away I go. Or, I can do what we call the cover-up method. Right? That's where I let x equal 0, and I let y equal 0. Well, if I let x equal 0, what's 5 times 0? 0. So I cover it up, so it goes away. So it's called the cover-up method, right? I'm left with negative 2y equals 10. And I can solve for y. Divide by negative 2. Y equals negative 5. So at 0, negative 5, right? 0, negative 5, I would have a point. Then I would let y equal 0. If I do negative 2 times 0, what do I get? Negative 2 times 0. 0. So I cover it up. I'm left with 5x equals 10. I divide by 5. X equals 2. So at 2, 0, 2, 0, I would have another point. Notice my points line up. They should. If I do it either way, I should get the exact same line. Figure out which way you like to do better and use that. And then draw your line through it. Draw arrows. And you're done. Alright? So either way, whether you like to solve for y and get y equals mx plus b, or whether you like to do the cover-up method, you should get the exact same line. Alright. Any questions?
I have one.
Hi, Mr. Keller.
Sorry to interrupt.
What is your question?
Can you do me a huge favor?
Yeah.
Yeah, this one's thing off with her. Does she
If
ever
she shows up, yeah.
Okay, did you give that to her?
Yeah, she's
Thanks.
here.
I was gonna give her this one too, but like, it printed like that, so.
That, she won't be able to read that.
No.
That'd be a shame.
Who's that?
It didn't go through, doesn't count. Bye. Nice. Bye, Mr. Keller. Alright. Let's try inequalities. To do inequalities, we're going to do the exact same thing. Graph it as if it's an equation. But when you go to draw your line, you got to figure out if it's or equal to, it'll be a solid line. If it's not or equal to, if it's just less than or just greater than, we're going to have a dashed line. Well, then we're going to choose a test point, figure out what side we want to shade on. If it comes out to be true, we're going to shade the side with the test point. If it's false, we're going to shade the side without the test point. Alright? That seems like a lot right now, doesn't it? It'll be okay. It's really not that bad. Let's try an example. Have you guys done this before?
Yeah.
You did this last year, right?
No,
You guys should be pros at this already. So, first thing you're going to do, guys, treat this like it's an equation. Y equals negative 2x plus 5. Right? Y equals negative 2x plus 5. How would I graph that? Where would my y-intercept be?
5.
5. So B is 5. So my y-intercept would be at 5. What would my slope be? Negative 2 over 1. So I would go down 2 to the right 1. Put enough points where you can draw a line with your straight edge. Now think about it. Is it going to be a solid or a dashed line? Ooh, dashed, right? It's not or equal to. There's no line under here. So it's a dashed line. If you struggle just drawing a dashed line, draw a solid line and then erase chunks of it. That makes it a dashed line. So it's dashed because it's just greater than. There's no or equal to. So the dashed line tells me, just like the open circle, I can't actually include anything on that line, but it's my barrier. Okay? Alright. So, we did our line. We got our line on our graph. Really good. Now we're going to take a test point that is not on the line to figure out what side I want to shade. Well, what test point should we take, you think? What would be the easiest test point to plug into an equation? Well, 0, 0, right? I will always take 0, 0 as my test point, unless it is on the line. If it's on the line, I can't choose it. Well, it's not on the line here, so I'm going to take 0, 0, and I'm going to plug it into my inequality. I get 0 is greater than negative 2 times 0 plus 5. I plug 0 in for x and 0 in for y. If this comes out to a true statement, I'm going to shade the side with the test point on it. If it comes out to a false statement, I'm going to shade the opposite side of the line. Well, I get 0 is greater than, what's negative 2 times 0? 0 plus 5 is 5. Is 0 greater than 5? No, it is a false statement. Which means I'm going to locate my test point, and because it was false, I'm going to shade the side opposite my test point. So I'm going to shade the other side of my line as my answer. So all of that should be shaded over there then. Because it's the false, I shade the opposite of my test point. Does that make sense? So that means anything over here, any point you pick in this shaded area, should make that a true statement. So if you're ever not sure if you shaded the right side, pick a point from where you shaded and plug it in. If it doesn't make a true statement, you shaded the wrong side. Alright? Should we try another?
I think so.
We only have like 18 more to go. So, next one's in standard form. 3x plus 3y is greater than 12. Hey guys, would you rather do the cover-up method, or would you rather do solve for y? Solve for y? Alright, we'll solve for y then. So if I have 3x plus 3y is greater than 12, I'm going to subtract 3x. I get 3y greater than negative 3x plus 12. And then divide by 3. Y is greater than negative x plus 4. Hey guys, what would happen if while I was solving for y, I multiplied or divided by a negative?
Changes. Flip the sign.
The sign would have to flip, right? So be very careful if you're solving for y in this, and you multiply or divide by a negative, make sure you flip your sign. Okay, if I wanted to graph this, pretend it says y equals negative x plus 4. What would my y-intercept be? What would my y-intercept be in this equation?
4.
4, right? So at 4, I'm going to put a point. What is my m, or my slope, in this equation? Really?
1 over 1.
Wait.
Negative 1 over 1.
Negative 1 over 1, good. So, that means I'm going down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. And as much as you need until you have enough points to use your straight edge. Okay, when I go to draw the line, is it a dashed or a solid line? Dashed, why, Carl? It's not or equal to, so it's a dashed line. Good. Alright, then pick a test point to see which side you want to shade. Is 0, 0 on the line? No, so I can use it, right? Always double check that. Test point 0, 0. Now, I personally always plug my test point back into my original inequality. You do not have to do that. I only do that because when I solve it, I might have forgot to like switch a sign or something like that. I don't want to mess it up. You can plug it into this one as long as you solved it correctly. But I'm going to plug it back into the original. 3 times 0 plus 3 times 0 is greater than 12. Well, 3 times 0 is 0, plus 3 times 0 is 0. Hey, is 0 greater than 12? No, not a true statement. Which means if I look at my graph here,
Shade the other side.
I see 0, 0's here, I'm going to shade the other side. It was false. So, shade the other side. So that's what our graph should look like then. We should have our line through dashed line, shade the other side. Alright. We got 3 of them left. Oh my goodness. How are we out of here?
21.
21?
13.
13, what? It is 13, oh my goodness. Alright, let's do... Hey, do you guys mind if we skip this one? This one's kind of... We've done one like that already, alright? Okay, so let's do this one. Y plus 6 greater than or equal to 4x. Okay. Can I graph it how it is?
No.
No, right? There's something by that y. So I'm going to subtract 6 from both sides before I do anything. Y is greater than or equal to 4x minus 6. So I got to graph that line. Where's my y-intercept at?
Negative 6.
Negative 6. Very good. Right? Y-intercept, negative 6. What is my slope?
4.
4
over 1.
Negative.
4 over 1, technically, right? So 4 or 4 over 1, so up 4 over 1. Up 4 over 1. Is the line I'm going to draw here going to be dashed or solid?
Solid.
Solid, very good. It's or equal to, right? Greater than or equal to, so it's solid. Let's take my solid line. Make sure I put arrows on it. And then I need to pick a test point. Can I pick 0, 0? Yeah, right? It's not on the line at all. So I'm going to take 0, 0. And I'm going to plug it back into my original inequality. 0 plus 6 greater than or equal to 4 times 0. Well, I get 6 greater than or equal to 0. Is that true? Yeah, 6 is greater than 0. So I'm going to take the side that has my test point on it, and I'm going to shade that whole thing in. These aren't that bad, are they? How do we feel on them so far? Good, so-so, so-so. Alright, the last one we're going to do here is going to be the toughest one I've done so far. And the only reason it's going to be tough is because X disappeared. Alright. Can I go to that next one so we're done copying this down? What? What's it look for, Baker?
We're just really surprised that X is so much.
Y is less than negative 2. X is gone. How do I graph something like that? Well, like I said, pretend it says y equals negative 2. How would you graph that? What's that? Okay. Negative 2 on the y-axis. Got it. So the y, okay. Is that it? There's just one dot? Let's think about it. Where else does y equal negative 2? Does y equal negative 2 here?
No.
No. Does y equal negative 2 here?
No.
Yeah.
Yeah.
Oh, yeah.
What about over here?
Oh, yeah.
Yeah. What about right
Is it
here?
just a horizontal line?
Yeah, it's a horizontal line, right? When y is equal to just a number, it's going to be a horizontal line because all of these points have a y value that's at negative 2. So I can just draw in a horizontal line. Now, should that horizontal line be dashed or solid? Dashed, right? It's just less than. There's no or equal to. So I'm going to do a dashed line. And then I need to pick a test point again. Can I use 0, 0?
Yeah.
Yeah, it's not on the line, so I'm good to go. So test point, 0, 0. Well, plug 0 in for y. 0 less than negative 2. Is that a true statement? Is 0 less than negative 2?
No.
No, right? Negative 2 is farther left than the number line. So this is false, which means I'm going to shade the opposite side of the line as 0, 0. So I'm going to shade down here. Remember, if you're not sure if you shaded the right side, take a point in your shaded region. Take any point. Let's say 0, negative 5. Plug it in. Negative 5 less than negative 2. I know I'm good. Does that make sense? Alright, any questions? Anything at all? Alright, subscribe, swipe up.
Yes, sir.